Hello friends, welcome to the new topic today on brewery process. This video is intended for automation engineer which will give them insight about the process operations in brewery. A quick overview on the brewing process. Typically, a brewery process can be divided into three big main areas. The first is the material handling, which consists of the storage silos and the milling section. The second section is the pre-house, which is also called as a hot block, while the third section is the cold block, also called as a cellar section. In a brew house is the heart of the operation where the brewing process begins. Each unit within the brewery process serves a specific purpose in transforming the raw ingredient into beer. The process starts from the material handling section, so all the grains are transferred to the milling. The milling unit grinds the grain into a coarse powder which is known as a grist. So this increases the surface area of the grain, making it easier for enzymes to break down starches into the fermentable sugar during the mashing operation. The next unit is called as a mash kettle. So the mashing unit mixes the grist with the hot water in a vessel. This is called also as a mashtun. So this creates a porridge like mixture known as a mash. So during this mashing operation, enzyme naturally present in the malt converts into the starches into a fermentable sugar, which is creating a sweet liquid called as a wort. So after the mashing operation, the sweet wort is transferred to the lautering unit, which is called as a lauterton. So after mashing, the liquid wort is separated from the solid grain material in a process. The lautering unit typically involves a combination of filtering and sparging to extract as much as fermentable liquid from the grain bed as possible. After the lautering operation, the wort is transferred to the next unit, which is called as a wort kettle. So this is a boiling unit. The clarified wort is transferred to the boiling unit from the lauterton. So this is usually a large kettle, and the wort is boiled and the hops are added in this vessel. So the bitterness in the beer comes from the hops addition. The boiling process also sterilizes the wort, killing any harmful microorganism present. So after brewing, the wort is taken to the whirlpool, which is not shown in this block diagram, where it is rapidly spun to create a vortex. This helps to separate a solid such as a hop particles and the proteins from the liquid wort and facilitate the transfer to the next stage for the brewing process. The final unit in the pre-house is a wort cooling, which is nothing but a heat exchanger which rapidly cool before the yeast can be added to the fermentation section. So this is a quick overview about the brew house. We will see the overview of rest of vessel in next video. So today we will discuss the first unit in the brew house called as a mash kettle. A quick overview about the mash kettle unit. So you can see that this mash kettle unit has a connection of the cold water, hot water which is coming from the water station. It has also the connection of the steel which is connected to the jacket of the unit. Also for the CIP also there are connection from the CIP system. The grist is also transferred from the mill which also comes to the mash kettle unit. There is an agitator which is required to agitate and uniformly distribute the wort, and at the output there is a transfer valve, there is a transfer pump and also a drain valve. So let's move and see what are the various operations involved in the mash kettle. So whenever we start the mash kettle sequence in the PLC, below are some of the important operations. The first stage is definitely the pre-checks. The second operation involved is the pre-draining of the vessel. The third operation is the preheating. The fourth operation is the mashing in, where the grist is taken into the kettle. The fifth operation is mash cooking, where there is a temperature profile and the wort is heated gradually with a 5-point profile. And the final operation is the transfer of the mash to the next unit. So let's move ahead and see each operation with the animation. So the first stage is the pre-checks. Whenever we start the sequence, so in this we check whether the manhole is closed. We also check whether all the control modules like all the valves, pumps are in the right position. There are no fault in the system. The associated units like a mill section from where the grist will be getting transferred is healthy and ready to transfer. The water systems are okay because we'll be taking the water. The associated pumps, valves in the water systems are in a healthy conditions. The steam pressure is okay. So these are the few prerequisites which we check before the start of the operation. Once these pre-checks are satisfied, the sequence moves to the step number 2. In the step number 2, it's a pre-draining. You can see the animation like the outlet valve and the drain valve are open. This is to empty the vessel for any residue present. This is followed by the preheating. So the hot water is taken from the water station and it is flushed through the tank to a drain. So this operation is a time based. So after a particular time, the pump is stopped to ensure that the adequate flushing is done. And once the low level signal is achieved, the outlet valve and the drain valve are also closed. So this completes the preheating operation. Moving to the next step, step 4, which is about the mashing in. So the first stage in the mashing is for the water collection. You can see like there are two control valves, which is for a cold water and hot water which is taken through the mixer where it is mixed, and the temperature what is required is tuned through the PID controller, and the required heated amount of water is taken in the vessel. So there is a set point of the how many liters of water you need to take. So this animation shows the filling of the vessel. The agitator is also started after a certain amount of the level is achieved in the vessel. So once the required amount of the water is collected in the vessel, the sequence moves to the next step, which is now to take the grist from the mill section into the vessel. The water system is stopped, and now the grist comes into the vessel. So all the relevant valve and the pump required at the mill section are also started during this operation. So once the water and the grist is taken inside, it is followed by the cooking operation, which is nothing but a temperature profile. Here you can see that there is a 5-point profile with a raised rise. So this can be bypass also. There should be a facility in the SCADA to bypass if any of the rise or rest is not required. So for example, the rise one is from 45 degrees to 52 degrees, and the given time is 7 minutes. So every 1 minute the set point changes, like it will be from 45 to 46, 47, which is given to this PID controller, and which manage the steam valve, which is a control valve. So in this way the mash cooking is done in this step. Once the mash cooking is done, the wort is ready to transfer to the next vessel. So in the mash transfer operation, the outlet valve is open and the pump is started. So the operation continues until the low level is received. Once the low level is received, the pump and the valve are stopped. The next step is to ensure the line chasing. So if there are any residues, it is chased through the hot water is flushed and the line is chased. So again it is transferred to the lauter tun, and after a certain amount of time, which is a time-based operation, the line is flushed to the drain. Similarly, once the low level signal is received, the vessel is completely empty. The outlet valve and the drain valve are closed, and this completes the mash kettle unit operation. The mash kettle again goes to the idle sequence, which is now ready to take the next batch from the step 1 to step 8. Thank you.